All right, so systems of nonlinear equations. We're going to start off with an example. This is the one of the examples I showed an image of in the previous video. This is the parabola and the line, and we're going to see if we can find solutions algebraically. So the two strategies that we talked about for linear systems, the substitution method and the addition method, are both still accessible to us, although the addition method is sometimes harder to use with nonlinear systems because x's and x squared, for example, you can't cancel those out. You can only cancel out like terms, which would have to have the same power. Anyway, we're going to use substitution for this example. So our first equation here, y equals x squared, gives us a nice easy substitution to do. Wherever we see a y, we can replace it with x squared. So our second equation in this system can be rewritten with the assumption that the first equation must be satisfied. We'll rewrite the second one as x plus 2 times x squared equals 6. Nice. So now we have eliminated the y's and we have an equation in terms of x only, and it's a quadratic. So let's just rearrange that 2x squared plus x, and then I'm going to subtract the 6 so that it's equal to 0. Now, solving quadratics, it's always nice to get it equal to 0, because then if we can factor this, that will be a nice, easy solution. So can we factor that? I could demonstrate the AC method if you all want. You can't tell me whether you want that. This is a video, not a class. Gosh, it's a little bit hard to get used to. But let's go ahead and demonstrate the AC method for this one. So in this case, this is in the format ax squared plus bx plus c. So our a is 2, our b is 1, and our c is negative 6. 0. So the AC method says, and I'm not going to explain really why this works because it's kind of just like it just does. It sort of works out this way. I'll explain how to use it, and that is you take the a value and the c value and you multiply them together. So this is AC is going to equal 2 times negative 6, which is negative 12. Then what we want to look for is factors of negative 12. So we want to try to factor negative 12 into a product so that the factors in that product add up to whatever the b value is, which in this case is 1. So you can list a bunch of factors of negative 12 and try adding them together until you find the one that works. But here, what's gonna work is I'm going to write negative 12 as 4 times negative 3, and then 4 plus negative 3 will give us 1, which is what we want. It's the b value, the 1. So with that knowledge, 4 and negative 3, what we can do is take our 2x squared plus x minus 6 and rewrite that as 2x squared plus 4x minus 3x minus 6. So we're taking the x, the 1x, and rewriting it as 4x minus 3x. And that still equals 0. Now the reason that's helpful is because now we can factor this by grouping. So I'm going to group the first two together, and I'm going to group the second two together. And the first two, I'm going to factor out any common factor, which would be 2x, leaving us with x plus 2. And for the second two, I'm going to factor out any common factor I can find. I can factor out a 3, but also a negative 1. So I'm going to factor out negative 3, leaving me with x plus 2. Now, if this went well, we should end up with the same factor left over, which is x plus 2, which we will now factor out from these two terms. So we'll end up with x plus 2 times whatever's left over when we factor that out, which would be the 2x minus the 3. And we factored it. Ta-da! So now we can say x plus 2 equals 0, or 2x minus 3 equals 0. And this gives me two solutions, x equals negative 2, or x is going to equal 3 halves. So I'm not done. We've solved for x, but what we want to do here is go and figure out what the y values would be. So we found the x values. Now we're going to go back and say, well, recall how y was equal to x squared. Well, we have two different possible x's. We need to find the corresponding y's. if x is -2, then y would equal -2 squared, which is 4. So that means that the point -2, 4 is a solution. That's one of our two solutions. There's a second one. So the other option is if x is 3/2, then y is going to be 3/2 squared, which is 9/4. So 3/2, 9/4 is another solution. And there we go. Those are two solutions to this system of equations we started with here that we get by following through these kind of two possible cases. We got a quadratic, we solved it, and we followed each of those solutions through to a corresponding y and got 2 points.